So I think you already know that, I have a thing about mathematicians and how they approach statistics. They approach it as a mathematician. They don't actually approach it in the way that people actually use the pieces. And so one of the things that I think, if you look at the things in the other 3 descriptive statistics videos, I'm going to argue to you it's a lot of factoids, right? And that's really the standard bit on how descriptive statistics are described. And that's where most mathematicians stop, right? And most stats books are written by mathematicians. They're not written by people who actually use that. And so what I want to do is I want to give you a conceptual framework, and I want you to think about how you're going to describe the data set to people, in particular people who don't understand statistics. This would be your boss. Your boss probably doesn't know statistics. Now, I could be wrong on that, right? There are some bosses who do, but if I listen to the majority of my students and my graduates, most of their bosses, not so much on the statistics. So here's the conceptual framework. It's a story. It's a story about the data, and it's a story with 4 parts. You want to tell me how much is in the data set? How many cases do you have? What is the data set and what are you measuring? That's the first part of the story. The second part of the story is to describing the middle of the data set, or the central tendencies. The third part of the story is to explain the spread of the data around the middle. And the fourth part of the story is to describe the shape of the data set. That's it. That's if you go up in front of a room of people and you can explain that, and then explain it in a way that they understand it nicely, you have accomplished a lot. And it doesn't need to be a long drawn out piece. You can do it pretty succinctly. And so we're going to do it here with the data set. We're going to use the Culver's data set that I have for the demo. The data set comes from the Esri Business data set from Data Axle. It measures sales in fast food restaurants across the U.S. in 2021. We sampled out and extracted just the Culver's data set and had a data set of 763 restaurants. Boom. That part's done. Always make sure that you transfer your tables into your report. And what we want to do is use this as the table. And so we're going to do that. And so the first thing we're going to do is describe the middle of the data set. And I'm going to move this here so that I can actually see this. Excuse me a second. So the mean of the data set is part of what we want to measure. We want to look at the median. We want to report all of these. And so you'd simply report them as numbers. And so one of the things you would do is, in this table, you'd have this table in your report, and you would talk about these different things. You'd list the mean as 1,923. You'd list the median as 1,894. You'd report the mode. You report the skew. And skew value is helpful to report in this particular case because I know that if it's within 0.5 of, if it's plus or minus 0.5, I know that then the data set's near normal. If it's a big number to the right or to the left, positive or negative, I know that the data set is skewed. I automatically know whether my middle is kind of symmetrical and my mean and the median are close together or not, which is one of the things that I want to know. Or I know that it's skewed in some way. And so And so that's the thing those are the things that I'm looking at having you do is describe what the middle is. All right. Measures of dispersion. How far is it measured, right? And the standard deviation will tell you that. The interquartile range. What's the range of the data, right? What's the range? What's the interquartile range? All of that begins to describe the spread. There's no single way to describe either the middle or the spread of the data. It's a collection of approximations. And so one of the things that I want you to think about is that you're not giving exact answers. You're giving approximations of what these things are. And know that the measures are going to differ, right? And so you're trying to paint a picture somewhat abstract. All right. Is your data bunched up or is your data spread out? This is where you would report the kurtosis, right? And that would let people know whether your data is kind of scrunched and peaky or this kind of spread out and flat. All right. I talked about this in the other videos, but I want to make sure that you know that this is a way to kind of really think about this and be smart, right? So both Chebyshev's theorem and the empirical rule here. So what I've done here is I have our mean and standard deviation for this data set. I know that if my data set's not normal, that 75% of the data lies within 2 standard deviations of the mean. So therefore, I know that the sales at Culver's restaurants, that 75% of the restaurants report sales between $526,000 and $3.3 million. 75%, I know that automatically for any data set. Boom, you're done. Here's the thing. If my data set is normal, then I know that 95% of the restaurants are between those 2 values, right? Because then I use that far right column and I say, okay, 95% are that. So I want to make sure that you are thinking about this because it is a way to kind of think about the spread of the data, and that becomes important. This is actually what the data looks like. And I think the skew on this was like 0.48 or something like that. So it's just barely in that. We can call it normal-ish data, but you could argue about whether it's skewed or not, right? And so this is what the data set looks like. It tends to be a little peaky, and so you'd report that as well. All right. One of the great errors that students have in this course is that they write like a mathematician and not like a business analyst. And so what I mean is this. They will say the mean is 1923, the mode, the median is 1894, and the standard deviation is 698. I will nail you for that, and here's why. First of all, you are measuring sales volume, and you're measuring it in dollars. And in this case, in this data set, if you looked at the numbers, it's in thousands, and so they knock the last 3 values off. So the actual mean data is 1.9 million, right, instead of 1900. And so you need to make sure you do that and you pay attention to that. You're measuring restaurant sales. Talk about that. It's not just about the numbers, it's about what are you measuring and what does that mean? Is that high? Is that low? How does that compare to other kinds of restaurants similar to Culver's? You can write about that in some different ways. And so I want to make sure that you think about this as telling the story of the data. It should describe, for a non-mathematician, what the middle, what the spread is, how big it is, etc. That's what you're aiming at, and that's what I'm going to push you toward.